So we're looking now at the problem that says a projectile is launched from y equals to y initial at v plus v initial at an angle. Then we look at find the work done by the weight in going from A to B. Is that the only force acting on the particle? And we're going to find that variable. So at first we know that work is just this equation here. Right? And we know we're looking for A to B in this scenario. So we know that this is a projection, by the way, this is just a projection of the vector F from M to the directions. Just so that you guys know what that symbol I wrote there for, sorry. And Y doesn't change, so it's going to be 0 in this case. So we know that F is also equal to mg, and we know that the work, is mg ya minus yb, and we know b is 0, right? So when we plug this in, we know that this is going to be positive because it is going upwards, right? And if we were to draw like a little free body diagram just to give us like an understanding of what's going on, delta S that I wrote earlier, right? And this is mg, right? From the equation work earlier, work is F delta S, which is just a projection of the vector of F moved to the directions, right? We see here that's our full body diagram with mg going down and delta S going up, or at least positive. Then we could figure out what this is, right? And we could find it with this. Okay, and we know this is 0, right, at the end, right? And we know that 0 is going to be equal to the KE difference. And then we just break this down further. From the 0 equal to KE, we go 0, KF, KI, minus K, I'm sorry. And then it's just going to be initial, the final, the kinetic. And then this essentially is going to turn into 1/2 NVB squared equals to 1/2 MV initial, squared. And then eventually it's just going to be VB is equal to V initial. Sorry. Yep. So that's our final answer. Since we're not giving any values here. If we were given values, we'd be able to plug it into each of these equations, and we should be left with something along the lines of this. Okay? Thank you. Now, let's go on to B. It says, find the work going from A to E, and A to C, I'm sorry, I said E, and the final VC. Okay? So essentially, we are applying conservation of energy, and no mechanical energy of A is equal to mechanical energy. So it's E mc times A, E mc C. So let me write this out for you guys to see what I'm saying, which is essentially going to be something very similar. We're going to be with this. Let me just write it out. Maybe it's better if I write it out. M squared plus plus 0, right? And the 0 being the mg4, 0 because it has no potential energy at the end. This is the potential energy at the end, by the way, the 0 at the end here that I'm drawing all over on. So after we write that out, we could work it out into a similar equation to VC squared equals to VA squared plus 2GY. like that. And essentially, that's going to be the equation that we could use to solve for this problem of VC, which, yeah, right here. So that's the answer for B. We worked it out from the original equation that I gave earlier with 1/2 m the last initial squared plus mgy initial square, and then you work it out from there. And you can see that it turns into VC squared equals MVA squared plus 2GY. Okay? So, perfect.